Alright, so starting the next unit, going to look at something called logarithmics. Okay, it is the inverse, or it is the opposite of exponential. So kind of up here, whenever we had to solve for the exponent, and I did two problems today. You put in y equals, go to the table, and then hit the down arrow for half your life, and then finally you get to your answer. Okay, you don't have to do that if you know how to use logs, and I think it's pretty simple. If you understand the idea of exponential, then the idea of logs is pretty simple as well. Alright, so kind of go through these first tables. The table 1, we're just completing it for 2 to the power of x. So 2 to the power of negative 2 is what? 2 squared is 4. So 2 to the power of negative 2 is what? Not negative 4. 1 over 4. 2 to the power of 1 is what? 2. So 2 to the power of negative 1 is 1 over 2. And then anything to the power of 0 is 1. Okay, so we'll take all of those and we'll flip them into that next table. So all of what were your y's are now going to be your x's. And what was your x's are now going to be your y's. It's been a while since we've talked about this, even though I mentioned it just a few seconds ago. But whenever you take your x's and your y's and then you flip them, okay, then those two, the relationship between these two are considered what? No, inverse. It is an inverse relationship. Whenever you're done with that, go ahead and come down here to the graph. I want you to plot the points from the first table, graph it as best you can. Do the same with the second table. You should get something similar to that right there. Okay, so we just talked about the table and what makes that an inverse. Obviously, if it's an inverse on the table, it's going to be an inverse on the graph. But how can I tell that they are inverses just by looking at the graph? What is that line called? What's the parent linear function? No, it's not asymptote.
It's a reflection line.
What line is that?
The reflection line.
What is that? Y equals X line. Okay, so says what is the relationship between the different colored graphs? I want you to put inverses because it reflects across Y equals X. Now, before I move on, looking at this, you know that whenever we had that exponential graph, did we have a horizontal or vertical asymptote? Horizontal asymptote. So, if logarithmic, if everything is opposite, then what kind of asymptote are we going to have here? Vertical. So, if you had this one, your vertical asymptote would be x equals 0 right there. Okay? With exponential, you're kind of looking to see how it flattened out horizontally. Now you're going to look to see where it flattened out vertically. Come down here, the inverse of an exponential function is logarithmic. I'll write this not in cursive so you can spell it correctly, even though I'm sure it's all over your notes typed up somewhere. The inverse of y equals 2 to the power of x is the function y equals log base 2 of x. Please familiarize yourself with how you pronounce that. Okay? Log base 2 of x. Okay? Log base b of a. That's how you would say that if you were trying to sound somewhat intelligent. Okay? So, kind of how, whenever we had the rational and then radical notation where we went back and forth one to the other, it's kind of the same. You're going to have to know how to go from exponential to logarithmic. And you can kind of remember this. You know, the b is now here, the x is here, the a is there. You can just memorize that if you want. But whenever you hear me refer to a method called fishhook, and you'll see why it's called this here in just a second, this is the way I'll do it. So if I have b to the power of x equals a, okay, and I can fishhook whether I'm going from exponential to log or log to exponential. You're always going to start at the base. Okay, the b is my base here. One thing that a lot of people forget, if I'm going to logarithmic form, the first thing I need to write is log. And I'm starting with my base, so I've got log base b. I'm going to go across to the a, so log base b of a, back to the x. So if I wanted to solve for x, and it's in the exponent, that's how I would solve for x. I would put in log base b of a, or whatever numbers are there, into my calculator to get that. The reason why it's called fishhook is just because if you follow that path, it somewhat looks like a fishhook. That's the only reason. If it's already in log form, so let's say you have it like this, and you need to put it into exponential form for whatever reason, you can do the exact same thing. I'm going to start with my base. Again, you need to have an idea as to what form you're writing. My base is, I'm going to raise it to the power of something. I follow that path, I come across to x, so b to the power of x equals a. So whenever you're having to convert from exponential to log or vice versa, I'm always going to tell you to fishhook it. Okay, do this, 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 and then fishhook it. Alright. This table down here I don't really like, so we're not going to do. So go ahead and go. Go ahead and go to this. And this is all we're going to do right here is go from exponential to logarithmic and logarithmic to exponential. Okay? So if I'm going from exponential to log, first thing I'm going to do is I'm going to write log. Then after that, dog it right there. What is my, with what I've circled, what is the base there?
3.
Okay. So I'm going to have log base 3 of what?
5.
No. 243 equals what? Equals 5. Log is always going to be set equal to the exponent. That's what logs are for, is to solve for an exponent. Now, I want everybody to put, you need to know how to put logs in the calculator. Okay, so kind of off in the margin, make sure you have this written down. It is going to be alpha, window, 5. And you should get something to pop up like this. And I want everybody to do log base 3 of 243 and make sure that you get 5 in your calculator. If you do not get 5, raise your hand and I'll come around and I'll see what you put in, because we need to fix this now before we get too far into this unit. So going to this one, Gabby, what would this be in log form? The next one. So what comes first always?
Log base 25 of 5 equals 1/2.
Awesome. Landon, the next one.
Log base 10,000
Of 10,000. Sam, the next one.
log base of 6. Or wait, no, yeah.
Yeah, log base 6 of
1/6 equals -1.
awesome. Max, the last one.
Log A.
Base A.
Like, you want me to say it like that?
Yes.
Log base A of C equals. Good?
Equals B.
I said that. Did I not say it?
So now going from log to exponential, you're going to do it's the same idea. Okay, so Cambridge, if I wanted to change this log statement to an exponential one, what would that be? So always start at the base. Okay, so 9 to the power of
1
equals.
Right?
9.
Oh, I guess that makes sense.
Okay. Connor, what about the next one?
2 to the power of 9 is 5.
Okay. Brody, next one.
8 to the power of 1/3 equals 2.
And Jake.
4 to the power of -2 equals 1/16.
Okay. Okay, if you understand going from one of these to the other, the majority, in which clearly, for the most part, I feel like we got a good grasp on it. That's the bulk of today's stuff. That's, I think, the first 12 questions on the homework. Going from this to this, and this to this, which should take you 5 minutes to do those, at least. Or at the very least, 5 minutes to do those. Okay, so let's go down here. So, certain properties that, if you notice them, they're just really easy properties, and they're kind of based on some of the exponential properties that we had with exponential stuff, which we'll kind of talk about even more next class. So, first, let's take these and let's fish hook all of them. So, I'm going to have log base 4 of 1 equals, and I'm not going to put what it equals to yet, log base 10 of 1, and log base 0.5 of 1. Okay, and so, but looking what's up here right now, what's similar in all three of those? The ones. So if you have log base, it doesn't matter, of 1, it is always going to equal 0. Because anything to the power of 0 is 1.
Same with the next thing.
Okay? Coming over here, because anything to the power of 1 is itself, if you ever have log base and then these two are the same, okay, these two numbers, it's always going to equal 1. Okay, because 4 to the power of 1 is always 4. 10 to the power of 1 is 10. 0.5 to the power of 1 is 0.5. Okay, so these are just very simple properties that whenever you notice them, it's going to make your life a lot easier. Okay. And if you start to see, if you start to read the logs still kind of as exponential, for me, that's whenever it really started clicking. I can look at this, and let's say I don't know what this is yet right here. Okay? I don't know that that's 1. I can ask myself, 10 to the power of what is 10? And I know 10 to the power of 1 is 10. Okay, and so there's going to be some of those that are really easy to figure out without freaking out that all of a sudden now instead of just a letter in an equation, now you got a whole word sitting in an equation. So these are just the properties of the examples we just looked at. So if I've got log base b of b, that's always going to be what? 1. Okay. Because b to the power of 1 is always going to be b. Log base anything of 1 is always going to be what? 0. Because anything to the power of 0 is 1. Alright, those log and those exponential properties, they kind of play off of each other a little bit.
Hey, we're almost done.
Yeah, today's notes are pretty short. Okay, so let's look at just the basic characteristics of exponential and comparing it to log. So this first stuff we'll fill in just for 2 to the power of x, which if it's exponential, my domain is always what? All real numbers. If I am looking at this graph, if you kind of look up here on the screen, that's what I'm putting in red. There's my exponential. If I'm looking at that, what is my horizontal asymptote?
0.
Y equals 0. And so what is my range? 0 to infinity. So now, whenever I go from exponential to log, if everything just changes, what is now all real numbers?
Range.
My range. My domain is going to be what? 0 to infinity. And what is my asymptote going to be? X equals 0. Kind of like the graph that we looked at the front. There's my vertical asymptote. So my domain is going from the asymptote to infinity. Alright, so that relationship is still going to exist. Whenever we were in exponential, your horizontal asymptote was always included in your range. Whenever you have log, your vertical asymptote is always going to be included in your domain. Alright, and then down here it says, what do you notice about the domain and range of inverse functions? You can just put that they switched. Okay. Switched. So now we're going to look at, we're going to graph our own exponential, find the inverse, graph that log, so that we can, again, we can compare them. So if I have 3 to the power of 2, what is that?
3 times 2 times 2.
No. What's 3 squared?
3 times 3. 9.
Which is 9. So 3 to the power of negative 2 is what? 1 over 9. 3 to the power of 1 is what?
1/3.
3. So 3 to the power of negative 1 is 1/3. Anything to the power of 0 is 1. So go ahead and graph those for me.
Ugh. How do you get that close?
What's my domain for the exponential? What's my range? Zero to infinity. What is my horizontal asymptote? Y equals 0. In graphing that, so let's think back a little bit because it's been a while since we've had to do this. If I have an equation and I'm writing the inverse of it, what do I need to do first? Flip what? Flip the switch? Flip X and Y. Now, this part right here is what will throw some people for a loop. You can fish hook this the way it is, but you've always got to remember that I'm going to start with the base. Okay, what is the base in this right here? 3. So I could fish hook it, so I would have log base 3, but now you're just going to go in the opposite direction. Of x equals y. Alright, so if you can teach yourself to fish hook both ways, depending on where the base is, that's fine. If not, you might want to practice rewriting it to where the base is always on the left, and that way you will only fish hook one way. So I would have log base 3 of x equals y. And then as far as the values that you would have in the table, my y's, what were my y's for the exponential are now my x's. What was my domain is now my range, and my range my domain. And then go ahead and graph that. All right, the last part of this. Look up here, please. Because I'm going to ask you to actually do a little bit of mental math here. Okay, and this is just practicing kind of what I referenced earlier. Looking at a logarithmic expression. Garrett and Max, put your calculators down, please. Looking at a logarithmic expression, but still kind of reading it as an exponential. So if I look at this, 5 to the power of what equals 125? 3. Because 5 times 5 is 25. Times 5 is 125. So log base 5 of 125 is going to be 3. 10 to the power of what equals 1,000. So 10 times 10 is what? 100. Times 10 is what?
3.
Times 10 is 1,000. So 3. 10 threes.
Which you don't want us using our calculator?
On most of these, you don't need to. Because
always be allowed to.
Because and we talked about this right here. If these two are the same, it's always what? 1.
But are we gonna always be allowed to use our calculator?
Yes. So on this one, and this one, some of you might need it. Log base 10 of what would give me 0.001? Okay, 1/3 or, well, it would be -3. We'll put -3. That's the way we'll see it. Actually, it wouldn't be 1/3.
-3.
-3. Okay, on B, 3 to the power of what
9.
is 81?
Four.
No.
4.
I read it. Oh, here it is.
On D, and we talked about this property.
Sorry.
Log base, it doesn't matter, of 1 is always what? 0. Two to the power of what is 1/2? -1. And 2 to the power of what is 1/4? -2. Alright? So, I need to talk to you about, now listen here. Just because we're at the end doesn't mean we're done. We're going to have to add something there. Yeah, it just blew your mind, didn't it?
That's exactly.
That just, you're like,
That's like
what?
exactly what it means. When
So-
you're at the end, that's exactly what it means.
Down here at the bottom it says the logarithmic with base 10 is what is called common log. And if you look down the left column of buttons on your calculator, the left column,
Be a hammer.
eventually you get to a button that says log. Okay? If you hit that button, that is going to give you common log, and it's a base 10. So, if there is no base written there, it's an understood 10. So it's just referred to as common log. So if you get this right here,
Does that equal 1?
log
Actually,
base, sorry.
it's okay.
So if you get this right here, okay, 100 is not the base. If nothing is written there, it's 10. So you would have 10 to the power of what is 100? That would be 2.
Fish hook.
Wait, but how would you write that? How did you
Okay.
write the calculator? Like, how would you...
Alright, something else that you're going to see on the homework that was not referenced on the notes. So you'll need to kind of write this in down here. Something that is called natural log. Okay? So if you remember, whenever we talked about exponential, the one weird thing in that whole unit was the e. There is a specific log that deals with e.
Ellen.
Okay? And so whenever you hit that, if on the calculator you got log, the very next button is ln.
Good guess.
Okay? And so everything we talked about today applies with natural log the way it does with log. You just write ln instead of log.
What is it?
Okay, so if you had natural log equals 4, and you're asked to fishhook this, okay, you would have, let's say you had natural log 4 equals 2x, I don't know, whatever. This base that you would start with would be e, and then you would just still fishhook it like we did. Okay. So whenever you see it's on the note or it's on the homework, I think 2 or 3 problems. But everything you do with it is the exact same thing that you did with log. Okay, the properties and everything else does not change. Okay.